Okay, guys, so we'll do 6-2. So it's more log signs today, but it's the ambiguous case, which is the angle side-side case, okay? I know, it's going to be an exciting day. All right, we're going to start with a picture. This picture is what I'm going to reference as far as different sides of the triangle. The A's, B's, and C's can all move around. So I'm going to draw you a picture that has water, a tree, and a rope swing in it, okay? So, you know, bear with my artistic skills here. So we've got water. Now your tree is kind of like a slanted tree on the bank. Things are probably not going great for this tree. And then we've got a rope swing out here. So I will reference all these different things. We'll talk about the tree side, the rope side, and then the water just kind of stays as the water. So I'll give you a second to draw that. Has everyone used a rope swing, like swung out into a lake? Yes. I feel like if you haven't, we need to like take a field trip or something. No? No? Okay.
I've like used one to like get across like a creek or something.
Okay.
But
not like just like swing out and jump. Okay. You're missing out. So I know it doesn't really look like a triangle, but these, we're going to use these as sides of the triangle. So the tree will reference, that's one side, the rope, and the water. Now, there's a specific way I want you to draw your triangles. So we'll come over here and draw a triangle. So the angle, you know, is always going to go in the bottom left here. So I'm going to call it A. Realize, given different information in the problem, it might be a different letter. But the one you know has to go in that bottom left, okay? And then you'll know two sides, and those are the two sides you need to label. This is why this is called an ASS problem. Again, in geometry, remember, you couldn't use this to prove two triangles congruent. Today, you'll see why. Like, it creates problems within your triangle. Now, to help you remember, like, I need the angle first, then the side, and the side. We're going to call this our ass rainbow. Okay? I'm telling you guys, it's quite the day here. And I know I'm not going in the right order of a rainbow. I know my Roy G. Biv, just rainbow. Okay? So always, always, always start with that angle you know in the bottom left corner. All right, we have several cases of things that can happen when you have an angle side-side situation. So the first case is that the rope is less than the height. Okay, I haven't drawn height anywhere up here yet. When I talk about the height of a triangle, what am I talking about? Yeah, what do you think?
From the top to the bottom.
Exactly. It's that perpendicular piece. We'll put it in here in green. That right there makes a right angle with the opposite side. That is your height. Okay? It's not one of the sides of the triangle. It's its own little measurement you can find. So let me draw for you what I mean here with rope being less than height. So here is the tree. Here is the water. And here is the rope. All right, this rope up here, it can move around. It can swing. It's a side of your triangle that can actually move. That's why I made it a rope, so the rope is actually going to swing back and forth. Even if I swing this rope all around, keep it the same length, is it ever going to touch the water side of the triangle? No. So if you have one side of your triangle here, this rope side that's really short, that case, you end up with no triangles, okay? Those will be your favorite problems to solve because you just say no triangle and then you are done. And again, what we're comparing that rope to, I made it short in the picture here, but remember you're comparing it to this height. So if the rope is less than the height, you end up with no triangle. We okay with the first case there? Case 2. The rope is equal to the height. Again, I've got the tree over here. Now, the water side, guys, I always make that long. We don't actually know how long the water side is. Like, that's not given to you. So I just kind of make this long side that we'll deal with. And then this is still the rope. So let's say this rope is equal. Apparently I made 2 ropes. So let's say this rope is exactly equal to the height of the triangle. What do you think happens? What does it look like was created?
A right triangle.
Yeah, so you get exactly one triangle and it ends up being a right triangle. So if the rope and the height are the same length, you end up with one right triangle. Okay, case 3. Part 1. Let's say our rope is greater than the height. And the rope is less than, so shorter than the tree side. same picture. We've got our tree, rope, water. Let you draw it, and then I'll explain this one. This is where it gets a little bit trickier. Okay, so let's look at this rope first. So your rope is something like that. Like it's, you guys see how that would be longer than the height, right? Okay. This rope is going to swing back and forth. So trying to keep it the same length, it could touch the water there, right? And that forms a triangle. Or swings over and could touch the water there. So when your rope is bigger than the height but less than the tree, you have two potential triangles. You could be here, or you could be here. So it creates an acute triangle and an obtuse triangle. So these are the problems where you have to solve for two different triangles in one problem. Okay? Do you guys see it though, how it could move and make two different triangles? This is why you couldn't use ASS in geometry. Because if you were trying to prove two triangles congruent, well, is it this triangle or is it this triangle? Because they're definitely not congruent. Okay? So we end up with two triangles. Questions on that one? We okay with the idea at least? I know we haven't seen it in a problem yet. All right, let's do the last case 3, part 2. Okay, this time the rope is again bigger than the height. And the rope is bigger than the tree side. We have a really long rope. So again, here's my tree, here's my rope, here's the water. We draw it the same every time. Okay, so let's look at this one. So my rope out here, okay, it could touch the surface of the water there, right? And make one triangle. If I try to swing this over with how long this rope is, first you're dragging yourself underwater and this is not going to be very fun. But could you hit the surface of the water again, or are you going to just like crash into the shore? Yeah, it's not going to go well. You wouldn't touch that same surface again until you were well past where the tree is, okay? So if the rope is really long like that, you just have this one triangle. Try one here and see how we do. All right, solve for all the missing parts. You guys do need your calculators again today. This whole unit, you need them. Let's round 3 decimal places. All right, you're given angle C is 42 degrees, side C is 70, side B is 122. And we're going to do this one together, okay? Now, when you see two sides and an angle given to you, you have to figure out, is this an ASS problem, or is it just side angle side? The way you figure that out is, look, does the angle match one of the sides? If that's the case, then it's an ASS problem. Okay? If you have two sides, one angle, and they match, ASS problem. Okay? All right. Where should I put angle C? The only angle we know. Bottom left corner, yes. Always, always, always. That's where the angle you know goes. So side C would have to go across from that, which was 70. Where do I put side B? Like where the tree was, right? Yeah, that's where B has to go. So this is 122. That makes angle B down here, angle A at the top, side A down at the bottom. Okay, take a second, make sure you're good with that setup. All right, just looking at it, we can't tell if it's 0, 1, or 2 triangles, okay? So we have to check. We have to look for the height. Remember, the height is just this little perpendicular distance in there. Anybody have a thought as to how I could find the height? Yeah. Sine of 42 equals what? Sorry. Perfect. Back to SOHCAHTOA, guys. Sine of 42 equals h over 122. So go ahead and use your calculator. What do you get for the height? Make sure you're in degree mode. Matthew, do you have one? You just forgot it. Okay. All right, perfect. I just want to make sure you actually have one.
You have one second for hours.
You've got to bring in your own.
Okay.
Yeah. You have one? Okay, perfect. Yeah, so just look on with someone around you who has one. Make sure you're good with how you key it in. And guys, for the height, you don't necessarily have to round to 3 decimal places. We're just kind of using this to determine what we do next in the problem. So what did you get for your height? Okay, so maybe I'll just say 82. Like, it's enough. Like, that's all I need to know to compare the rope over here to that height. Okay, remember this is our rope. So what do you think? Is the rope less than, greater than, or equal to the height? Less than. The rope is less than the height. All right, 70 is less than 82. What does that tell us? Yeah, no triangle, right? That was case 1. Rope less than height, no triangle. So you just tell me, no triangle, there's nothing to solve for, and we're done with the problem. you know, I drew this as an actual triangle that's connected, but that side that's 70 wouldn't actually touch the bottom side with how short it is. Okay? It's what?
That's confusing.
Because I drew it with it being a regular triangle. Yeah, what it actually looks like is, so you've got your 122 side. We don't know how long A is, and that's what's actually happening. But you don't know it until you find the height. All right, we okay with number 1? Okay, let's try number 2. Let's do A is 120 degrees. Little a is 45. Little b is 36. Okay, I want you guys to try to label your triangle. I'll give you a minute to do that, and then check with your neighbor. Did you put the angles and sides in the right spots? And do you guys see why this is an ASS problem? Yeah. Okay. Yep, these match, right? If you got 2 sides and an angle, and that angle matches with one of the sides.
So basically, if you're given any of, like, if any of your given information is to the same letter, then it's
Unless you were given angle side. So you gotta have 2 sides in there for it to be an ASS problem. Yep. Yeah.
Why does the B angle have to be to the right of the C angle?
Why does which angle?
Like B angle, it can't be to the left or on top of the C angle.
So we want to draw it consistently so that we stick with, okay, this is the moving side. Like if you put A over here, then 45 would have to be here, and let's say you put like 36 down here, and you set it up this way. All right, which side is the moving side? It is, yeah, and which way does it move? Do you see how it's like harder to see?
Yeah.
And actually it's A is the one that moves.
Oh.
Yeah, this guy right here would be, that's the one that would move, and I think it's just way more confusing. So if you draw it in that rainbow angle, you know, bottom left corner every time, then it's consistent with like, which one am I comparing with the height? Because if we set it up this way, like that's the height you need to find.
Oh.
Do you see how it's harder?
Yeah.
Like you can't, it's not wrong to do it that way, but it's just so much harder to see.
Yeah.
So that's why we try to take some of the confusion out with it. So I would put the angle I know. Goodness, maybe. So the angle I know goes down here. That's across from it. This one's got to be 36. Does that help? Is that how you set it up?
Yeah.
Okay. So again, it's not wrong. It's just harder. All right, guys, are we okay with the setup? Do you think my triangle's drawn to scale? No. Does that look like a 120-degree angle on the bottom left? No. It's clearly not drawn to scale. That's okay. What do you think is going to happen in this case? Like, what do you think is going to be true about this height? Even without finding it, is there anything you know about it, like referencing anything else? Does it have to be smaller than 36? Yes. Why?
across, and you know the length of this.
Well, yeah, like we know we've made a right triangle in here. Obviously, this doesn't make sense with 120 degrees. But shouldn't the height, a leg, be shorter than the hypotenuse?
Yeah.
Yeah. And again, with that 120 degrees in there, it's a little weird. So what do you know about 45 for sure, without even finding what h is?
It's longer.
It's bigger, right? Okay. So the rope over here is definitely bigger than the height. And isn't it also definitely bigger than the tree? So how many triangles are there? One. Now, you also could have figured that out with this being an obtuse angle. If you're given an obtuse angle, you're not going to have multiple triangles, okay? Because you can't swing that side over and create an obtuse angle. So when you see an obtuse angle here, good indicator that, hey, I'm only going to solve for one triangle. So now we're back to solving the way we did with law of sines in 6.1. So let's set it up. So I'm going to do sine of 120 over 45. What am I going to set that equal to?
Sine B.
Yes. Over?
B.
And-
Over 36.
Yes. Good. Yes, that is side B. So I've got 36 sine of 120 over 45 equals sine of B. What do I do with that on my calculator? How do I find an angle on my calculator? Clear all of this here. What do I use? Think back to solving equations and just evaluating things from the last unit. If you wanted an angle as your answer, what did you use?
Is it inverse?
It is inverse, yes. So on the calculator here, if I push second and then sine, that gives me that little inverse sign. That's what I want. And guys, do this all at once. I'm going to put in that whole fraction that I had. So I'm going to do alpha y equals to get the fraction key. And then let's see, what did I have? I had 36 sine of 120 over, I think, 45. Now, guys, I didn't check the mode here. I may or may not be in degrees. We'll find out in a second. Oh, good, I am in degrees. Okay, if you are not getting that on your calculator, raise your hand. Let me come help you, okay? Anybody calculator troubles? Don't be shy.
So that's giving you just what B equals, right?
That's angle B and you're done, yes. You could type in like the 36 sine of 120 over 5 and get that decimal answer, but then you'd have to take that whole decimal answer and put it into the inverse sign without rounding at all to get this answer. So I like to just key it in all at once and then be done with it. We okay? Okay, we're going to do something with this answer that we haven't done yet on our calculator. We're going to store it, okay? It's not as big of a deal for this problem, but some of our later problems and law of cosines problems, it's very important that you know how to store, so we'll just practice it now. On the left, do you see the little key, the STO, way down at the bottom, just above the on key? You're going to hit stow, and it should pop up with answer. And you have to tell it where you want to store this answer. So I think this was angle B, right? So I'm going to do alpha B, and then push enter. I have now stored this in my calculator as B. Okay, so let me go back to the problem here and we'll jot down this answer. We'll come back to this stored value. Anybody questions on the storing keystrokes? We're going to do that a bunch today. Okay. So I'm looking for angle B, which we had 43, I think it rounded 854.
Yes.
Okay. And then I still need to find angle C and side C. Okay. Now that I know angle B, how can I go about finding angle C? Come here. Yes, we know there's 180 degrees in a triangle, right? So let me pull the calculator up again. You're going to use the stored value. So I'm going to do 180 minus, let's see, our given angle was 120. And then I'm going to do minus B because I stored that answer as B. And so you get this lovely big decimal again. I'm going to store this answer. So what would I store this as, do you think? C, sure. So I'm going to hit stow, alpha, C, enter. Anybody stuck? Okay, let's go back. So I can record my angle C here. I think it was 16.146.
Yeah.
Okay. And now you're probably looking at this going, why the heck did I store that answer? If I had just subtracted this rounded answer, I'd have that. True, you absolutely would. But we are now going to use angle C to find side C. And if you use a rounded answer to find side C, you'll be off. Okay? So that's why we have to go through storing and storing to get to this final side. So let's set up our equation to find side C. What do you think, guys? What should I set up? Sine of 120 over 45, right? I know that part for sure. Yeah, I'm going to put sine of C, and I'm going to like circle it like, hey, I have a stored value for that over little c. So little c is what we're actually solving for here. Okay. You've probably gotten pretty good at the algebra part of this. Little c is going to equal 45 sine of that stored c over sine of 120. And I'll show you on the calculator. Are we okay with the setup, though? The algebraic part of it? Yeah? Okay. Okay, so I'm going to do the fraction key. And I would do 45 sine of that c that I stored over sine of 120. Are you getting essentially 14.50? Yes. Okay. Let me jot it down. Oops. Sorry. It was 4/5 over. Okay, guys, questions on that one? again. And guys, anywhere if you're like, whoa, my calculator didn't give me that, just let me know. Happy to help. It's so easy to like miskey something. You want to get that squared away. All right, let's try again. Angle B is 43. Side B is 186. I don't know why I have such large sides here for you. And side C is 249. Okay. All right, so draw yourself a triangle. I'm just going to walk around and make sure you guys are drawing them correctly, and stop me if you have questions on anything, okay? I'll just kind of be looking at what you're doing. You don't have to try to do the problem yet. I just want to see your setup. So sometimes we use Greek letters for the angle. You know, Greek letters like put in a box, do something so that we can fold it like. That's why they say for the pick not ABC.
Yeah.
Because C and you want to start finding the height. And everybody's trying to get right. Okay, let's find the height, guys. So I would use SOHCAHTOA here to find it. Sine of 43 is going to equal h over 249. So approximately, what do we get for the height here? 170, good. So do we see that the rope is bigger than the height? And are we okay with rope is also less than the tree? So what does that mean? Two triangles, of course, right? Two triangles. Done.
All right, that's fine.
You what?
Should I bring the decimal?
Oh, sure, thank you. Okay. The first triangle you solve for is just exactly what the triangle looks like and how we've solved for all of our other triangles. Okay? So let me get the height out of here so we can set that up. So we'll call that the things we have to find. I'll say angle A sub 1, angle C sub 1, and little a sub 1. Like this is our first triangle, okay? All right, so now you're just using your law of sine. So we're going to do sine of 43 over 186 equals what? What should I set that equal to? Should I do sine of A over A? No, that's two variables. We don't want to do that one. Yep, sine of C over 249. So this is going to give us that 249 sine of 43 over 186 equals sine of C. What do I do with that on my calculator? Yeah, that's where we do the inverse, okay? So I'll get this stuff out of here. So inverse sine, because I'm solving for an angle, and then I'm going to put a fraction key in there. And then, let's see, large numbers, 249 sine of 43 over 186. Ooh, not 1886. Yeah, are we getting 65.923? What do you think I need to do with that answer? Other than write it down, what else should I do? Store it, yes. What am I going to store it as? C. So sto alpha C. Enter. Are you with me, guys? Okay, so far? All right. Okay, so let me go back, jot that down. 65.923. So how do I find angle A? Yeah, so we've got to do the 180 minus 43 minus that angle C you just stored. Minus 43 minus C. We're getting 71.077. Okay. What do I have to do with that? Store it as A. I think that's what it was. Store alpha A, enter. And stop me if I go too fast through any of those guys, okay? All right, so that one was 71.077. One more thing to find in our first triangle. So we're going back to law of sines now. So I'm going to do sine of 43 over 186, since those I know for sure. And then that's going to be sine of my stored A over little a. So little a is equal to 186 sine of stored A over sine of 43. All right, 186 sine of stored A over sine of 43. All right, we get 257.988. You don't have to store this one anywhere, okay? It was the last piece of the triangle. We don't need it for anything else, so we don't have to store that. All right, so go back and jump that down. Questions anywhere on that first triangle? We're okay. I see a couple people still typing things in, so I'm going to wait a second here. All right, I still have to find the second triangle here. I'm going to draw a new picture so that you can just see what's happening with the sides a little better. So I'm going to come down here. Maybe I'm going to draw a better triangle. All right, so I'm going to label it the same. This was B, 43 degrees, 249, A, 186, and C, little A. Okay, so all the same pieces we started with. We are just now going to find the other triangle. Okay. What happens, the rope swing side over here, it moves. The side that's 249, the length of that cannot change. The angle that is 43 degrees can't suddenly be a different size angle. This can move. It is still 186. Okay. Little a, do you see how it's gotten a lot shorter? Side A. And what about angle C? You see how it got bigger? Okay. Let me draw, we're going to call that A sub 2, C sub 2, just so we can keep it straight. And what happened to angle A at the top? It got smaller too. Okay, so that's A sub 2. If you think about it, let me draw another side in. Make you a different color. Okay, so that blue side is also 186, right? These are congruent. That's the old triangle. It got moved over. What do you remember from geometry about isosceles triangles? Two congruent what?
Angles.
Yeah, so two congruent sides, the angles opposite those sides are also congruent. The base angles are congruent. This is the angle, and actually I'll go blues. This right here, that was C in my first triangle. Okay? I know it's going to be congruent to this one right here. And what I'm looking for C2 is this guy. How could I find C2?
180 minus C.
There you go. You guys see how they're a linear pair there? Okay. So to find C2, that's one of them I need to find. A2, A2. To find C2, you're just going to do 180 minus C1. And we stored C1, right? So let me go back. So I'm going to do 180 minus C. You're getting 114.077. What do you think I need to do with that value now? Store it as C. We can't really store it as C2, like that's not a thing. So we're just going to store as C. Store alpha C. Okay. I clicked too many. Sorry, guys. So this one was 114.077. Is everybody okay with, even though this has formed a triangle over here, like this is not the triangle we're solving for. Okay, we're back over here with the tree and the rope and all of that. We're just using all of this to find the pieces over here. Okay. All right, so I've got angle C2. How can I find angle A sub 2? There you go. Lots of subtracting. 180 minus the 43 we know, minus the C2 we just found gives us A sub 2. So 180 minus 43 minus that stored C value. You're getting 22.923. What do I need to do with that? Store it. You're going to be really good at storing. Store it as A. Let me go jot it down. 22.923. How do I find little a? Law of signs. Yep, back to law of signs. Excellent. So I'm going to set it up sine of 43 over 186 equals sine of that stored a value we just found over little a. And go ahead, you're solving for a sub 2. Add in. Using that stored value again. What'd you guys get for side little a 2? Yes, 106.226. Okay. So, is it more work when there's 2 triangles? Obviously, yes. But that second triangle, the majority of it is just subtracting from 180. Okay, to find both angles, you're just using 180 minus a couple of things. Questions? Yeah.
Can you explain how like C2 works in it? Like how?
Oh, how I found that? Sure. So back in geometry, we knew, like, if these sides were congruent, you knew those angles were congruent, right? So this was our original C that we found over here. Okay. The part of our triangle, like, this was that angle that was given to you. This you knew, I think it was 249. This changed, this changed, this changed. Okay, so to find this guy, do you see it?
Yeah.
Okay. Yep. Once you see it, it's like, oh, that's not that hard. But until you see it, it's like, what are you doing on that? Okay, should we do one more 2 triangle one, guys? No. You just want to practice it on your math space? One more? Okay, one more. We'll put one more up here. If you'd rather start on your math space, you're allowed, okay? All right, let me make one up that's going to work. Let's see. B is 37. Side B is 12. Side A is 15. That should work. I don't know what to do. I'll double check myself, guys. Okay, we're good. So you guys try this one all the way through. I will tell you it's a 2-triangle problem. Work together if you need to.
this, the angle on
You don't struggle with it.
Okay.
It wouldn't really matter, but there's no reason. It's also easy to like Guys, I'm gonna put the answers up here so you can check when you're ready. Thank you.
For some reason on our tests, we like bring it to the simple, and our kids not very necessary.
So your tests will all be on MathSpace. Oh, you were probably in the hallway when we were talking about that last time, so. Get good at entering it on MathSpace, okay? You miss one? So again, guys, when you're ready, you can check up here. Then use your time to work on MathSpace. If you have questions on any of these or any of the MathSpace, let me know.